Welcome back to this series of videos on EVPN-based VXLAN management with IMC. This is part 3 and last video focusing on some capabilities in IMC to monitor VXLAN, some test and troubleshooting of the overall lab scenario. Getting back to IMC, let's have a look at information that IMC will dynamically discover. Let's start with tunnels. Due to the dynamic nature of them in the context of EVPN, no tunnel was previously provisioned during the configuration. So let's click on tunnels. And you'll see here there is two tunnels, tunnel 0 for between leaf 1 and leaf 2, source and destination, source being leaf 1 and destination being leaf 2, and tunnel 0 between leaf 2 and leaf 1. So these tunnels are actually carrying two VXLANs. So this is what has been completely discovered dynamically with IMC. It does correspond in the CLI in the interface tunnel that you will see. So if I go to display configuration, you'll see that there is no tunnels actually configured. However, if I do a display interface tunnels, you'll see tunnel 0, that is source leaf 1, destination leaf 2. Okay, so that's first. Then let's go to devices. So let's take leaf 1 for instance, and let's see what remote MAC address has been discovered on leaf 1. So as you can see here, those remote MAC addresses are the MAC addresses learned dynamically through EVPN thanks to BGP routes received with MP-BGP between leaf 1 and leaf 2 through the route reflector. So this is the kind of information that are very useful for troubleshooting. If I get back to the slide just to explain what we did, we like to have the remote, so I'm on leaf 1 and I like to have the remote MAC address, for instance on VM3, VM4, so you see it's B4-2D and 8C10. So let's get back to that, it's 8C10 and B4-2D. So this is as expected the remote MAC that we learned. Let's have a look now on the topology. So I click on VXLAN topology. So you will have so leaf 1, leaf 2, and spine. So this is the physical view. So if I click on the equipment, I will get some information about the loopback IP address, for instance, the runtime, the status, if this is normal, warning, and so on. If I click on the link, I will have the obviously the physical interface port that is connecting the equipment. And most interestingly, we'll see the business topology, where per VNI, I will have the view of what is the tunnel transporting the VXLAN for that given tenant and that given VSI. So here, for instance, I'm carrying VNI 10,010 between leaf 1 on the left to leaf 2 on the right side for tenant 1. And the VSI information are specifically being flagged here. We've got tenant 1 on the left side that want to communicate with tenant 1A. So again, very practical for troubleshooting standpoint. So now let's try to test a little bit traffic between those virtual machines. So to recap what we'd like to do, we want to, for instance, test that traffic within tenant 1 between virtual machine 1 to virtual machine 3 and the server 5 here. That traffic is passing through the VXLAN. Same for tenant 2. Remember, at this stage we do not have configured any routes leakage on spine 1. So let's get back to this time vCenter. So I'm on virtual machine 1 and I'm going to ping 10.9, 10.11, which is VM3. So we have that traffic that is ready. Now let's move to the traffic between VM1 and server 5, the bare metal server. That's an emulated server, by the way. It's still a virtual machine with dedicated interface, but as if it was a bare metal. So let's get to that. And we have the capability to reach that server as well. So let's now focus on tenant 2. Okay, so ping 10.9.20.11, and that one was 20.10, so I can ping 20.11 without problem. So we see that communication within a VRF tenant is working nicely. Let's have a look now if I want from tenant 2 to ping tenant 1. So as you can see here, I cannot do that. So this is on purpose, meaning that on the border, so here this is the spine, on the border gateway, or the gateway that is able to communicate between all the VRF, I did not configure the import and the export of the global table. So this is why I cannot communicate here. So let's configure the missing part on the spine. So let's get to the spine. So I need first to configure the global VRF. IP-VPN, let's call that VRF global. Hot distinguisher, I'm taking the same convention, the IP loopback address :1. As a target, VPN target, I'm going to import the 2 VRF and I'm going to export them to all VRF. Okay, I could have done that per address family EVPN IPv4. I'm going to do that only globally. Let's check on leaf 1, for instance, what is the routes information available per VRF. So display IP routing table, VPN instance, VRF tenant 1. And you'll see that there is no route information for tenant 2, and there is no default route neither. So what I propose to do, instead of importing and exporting the route per tenant, I'm going to simply import for each VRF the default route, so that in order to go outside of the given VRF routing table, it will follow the default to reach the spine. So for that, I need to export the default into the VRF global that will be then exported on each VRF. So I'll do that on the spine, and to do that, I will do that with BGP. And at the same time, I'm going to set up a BGP peering with the core infrastructure, so let's say the campus core, for instance, in order to have internet route access. So let's get to the configuration and see the interface facing the internet core. So that would be 100 gig 1049. I'm going to bind this to the VPN VRF global, and the IP address that is used is 10.10.2. Okay, here we are. So now I have to get back to my BGP configuration. And inside BGP, I will have to define on that VRF global the peering for my internet core, and as well to import the default. So let's get to the VRF global VPN instance. I'm defining my peer, so it's an external BGP peer with the autonomous system being 7777. Okay, now address family, that would be inside IPv4. I'm going to do a default route import. Going to import static route as well for further testing. I have a route policy that I'm using on the core to accept only routes coming with a given community. I already predefined that that route policy, that is EVPN to internet export, and I will advertise the community to get that accepted. Then let's see the BGP peering. Okay, that's established, and you see there is 152 prefixes exchanged. Now let's have a look on leaf 1. Okay, so at this stage I still not have the route coming on leaf 1. For that I need to assign for the global table on the spine the layer 3 VNI in order for the leaf 1 to receive the route. So, and to do on the spine to do the lookup between the VNI. So the VNI for tenant 1, the VNI for tenant 2, and the VNI for the global table. So let's configure all those VNI on tenant 1 as well. I may have to configure L2VPN capability as well on spine 1 to achieve that. So interface VSI, and that's let's say 501. That's L3 VNI. The VNI ID I define for tenant 1. Let's do the same for 50,002. And I'm going to use the same VSI interface value that I did before for the global routing. So I'm going to bind that to the VPN instance VRF global and L3 VNI 51. Okay. I guess I already configured L2 VPN as a background on that switch. Yes, you have here L2 VPN enable. If you do not set up L2 VPN enable on the switch, you won't be able to configure the L3 VNI information. And now let's have a look on spine 1, on leaf 1, sorry. Here we are. We have now the routes being propagated up to leaf 1 for a given tenant. Thanks to that lookup we have through the VNI on spine 1. So now I should be able to ping from VM1, VM2. And here we are. So from VM1 to VM4 works as well. From VM2 to VM4 we did that before, so it should work. And from VM2 to VM3 works as well. And VM2 to server 5 works as well. And let's try now VM2 to, let's say, internet. So I've got an IP that is a loopback of my border of my infrastructure. Yes, I can ping that IP. So this is something that works now. Everything, all the flows that we have in this scenario are actually working. So what can be interesting now is to take a look at IMC back in terms of monitoring to see if IMC discovers something more, since we have this capability to have border VTEP capability and connectivity to over VRF. So let's go to the tunnel tab and see if we have actually, remember we have one tunnel between leaf 1 and leaf 2. Now we have two tunnels, still the same one than before between leaf 1 and leaf 2, and the other one, this one between leaf 1 and the border to actually go and exit from the VRF. So that's very useful information as well for any troubleshooting. Now something that would be useful is to start some Wireshark packet capture on the spine to see traffic between virtual machines. So let's select, for instance, VM1 and let's have a look at pinging VM3, so inside the same tenant, same subnet. Okay, and I prepare Wireshark behind. So this is that. So let's take a look at the VXLAN header. You see, same tenant, same subnet. The VNI is 10.0.0.10. The IP address for source and destination traffic. So the source is leaf 1, destination is leaf 2. Let's have a look at traffic if I do ping to server 5, the bare metal server. That's 11.10. So let's stop it. So packet, the request. So the request, it's IP source and destination that is leaf 1 to leaf 2. And let's consider the VNI now is 50,001. This is due to the fact that we are within same VRF tenant but different subnets, so different VSI. So we are going to have a layer 3 lookup inside the switch and encapsulate that in the VNI used for inter-VXLAN routing. So packet back, you see that it's the same VNI, so we have a symmetrical IRB here, and we have the destination port being the same for UDP VXLAN. Now let's take a look at traffic between VRF1 and VRF2 on the same switch, so tenant 1, tenant 2. So I will have to go to this border in order to exit and to re-enter. So that's 20.10. To help understanding what is the Wireshark packet about, let's recap on the drawing. What we have VM1 pinging VM2, so we have to go to the border in order to exit the VRF and to re-enter to the other VRF. So that's why we've got some air-pinning traffic, and therefore you will see, for instance, twice the packet count on the interface here. So let's get back on the Wireshark to analyze the packet. You will see that from leaf 1 to border spine, here you have the VNI ID 51000. Then you will have from the spine to leaf 1 the VNI encapsulation being set to the VRF number 2, 50002. And then for the echo reply, we'll reply inside the inter VXLAN inter-tenant VNI 51000, and the packet will be from the spine to leaf 1 inside the tenant 1 VRF. So that gives you a detailed explanation of what happens if you have to go up to the border to get packet forwarding. Last thing before closing is the capability of IMC to monitor VXLAN. So if you go back to VXLAN list, you see all your VXLANs, and you have the capability to select one of it or all of them and monitor. So as it's taking a while to grab traffic, I previously did a monitor action on the first VXLAN, and inside operation you can click on traffic information and have a view of the traffic for the last hour or last week, last day, and so on. So very useful information as well for monitoring. That concludes our EVPN-based VXLAN management with IMC. I hope that it was worth spending the time in watching the video, and if you really like that, please let us know, and let's elaborate on a further demonstration you would like to see. Thank you for your attention.